Section 3.2 is applications of systems of linear equations, and you guys might have figured it out by now, but when I say applications, I mean word problems. So for example, a rectangular soccer field may have a width between 50 and 100 yards and a length between 100 and 130 yards. One soccer field, here's a soccer field, has a perimeter of 320 yards. Its length measures 40 yards more than its width. What are the dimensions of the field? Well, I need to get two equations. First off, I know because I have a rectangular, perimeter equals 2 times the length plus 2 times the width. So I know that 320 yards, don't forget your units, yards is 2 times the length plus 2 times the width. I'm also given a second equation, that my length measures 40 yards more than my width. So if I took my width and add 40, I'd be equivalent to my length. I can now use substitution to solve. I can substitute in for L. So I have 320 equals 2 times W plus 40 plus 2W. 320 equals 2W plus 80 plus 2W. 320 is 4W plus 80. I subtract 80 from both sides. 240 equals 4W, so 60 is W. I divide both sides by 4. So now, and that is correct, right? We can have a width between 50 and 100 yards. So my width is 60 yards. It's asking me both dimensions, so I need to solve for the length by substituting back in. Length equals 60 plus 40, so my length is 100 yards. So the dimensions of this soccer field are 60 by 100 yards. This second example we'll solve by elimination. So for the 2015 to 2018 NFL and NBA Association seasons, 2 football tickets and 1 basketball ticket purchased at their average prices would have cost $241.84. 1 football ticket and 2 basketball tickets would have cost $204.74. What were the average prices for the 2 sports? We need to set up an equation. Let's solve this one using elimination, just for practice. So I have that 2 football tickets plus 1 basketball ticket. So remember, we don't normally put the 1 in front of it, but I'm going to do that real briefly. Is $241.84. Notice I used variables that make sense. Now I primarily use X and Y, right? Those are my favorites. But when I'm working with football tickets and basketball tickets, it's pretty easy to, it's simpler for me to see if I represent football tickets with an F. So I've got 1 football ticket and 2 basketball tickets for $204.74. So now I have a system of 2 equations. And I'm going to go ahead and erase this coefficient of 1 because it was just for me to get my equations all set up. I have no additive inverses as coefficients here. So I'm going to multiply this bottom equation by -2, so my f's cancel. So that's going to give me 2f plus b is $241.84, and -2f minus 4b is $204.74. So if I add these together, I get -3b is -$167.64, and I get b equals 55.88. So a basketball ticket costs $55.88 on average. I can use this to solve for a cost of a football ticket. So we'll take this first equation. 2f plus b, which is now 55.88, is $241.84. So 2f is Oh, I did the math wrong on this. Okay, so I'm going to go ahead and subtract. This is the sound of me getting out my calculator. So I've got 241.84 minus 55.88. That's 185.96. And I go ahead and divide that by 2. So I get that the average cost of a football ticket was $92.98. So my answers are that the average basketball ticket was $55.88 and the average football ticket is $92.98. And as I have never been to a basketball game or a football game, someone else will have to tell me if that's true. For our last example, this is a chemistry application problem. It is how many ounces of each of 5% hydrochloric acid and 20% hydrochloric acid must be combined to get 10 ounces of solution that's 12.5% hydrochloric acid. So when you see a problem that's chemistry based or interest based or involves a lot of percentages, that should really be a hint to you to use that table method we talked about in chapter 1. So I've got the ounces of solution. I have the percent concentration, and I want that as a decimal. And then I have the ounces of pure acid. And I knew I was working in ounces because it told me abbreviation OZ. So how much of each of these two types of acid must be combined to get 12.5% hydrochloric, 10 ounces of 12.5% hydrochloric acid? So there's some things I don't know. For example, I don't know how many ounces of 0.05% acid I'm using, but I know I'll have 0.05x ounces of pure acid if we let x be the numbers of the solution, the ounces of solution of 5% hydrochloric acid. I'll let y be the ounces of 20% hydrochloric acid. So I know I'll have 0.20y, I guess I didn't mean that extra zero, 0.2y ounces of pure acid. And I need to get 10 ounces of 12.5, sorry, 0.125% hydrochloric acid. So that would be 1.25. So now I've got two equations. I know that x plus y has to equal 10, and I know that 0.05x plus 0.2y has to equal 1.25. Now I'm going to multiply this entire equation by 100 to get rid of the decimals. So let's give us some more room to work. I'm going to use a whiteboard for the first time in these videos. Hey! So I have x plus y is 10, and 5x plus 20y is 125. So I'm going to go ahead and solve this by elimination. I want my x's to cancel out. So I'm going to multiply this equation by -5 on both sides. And this notation is really for me to keep track of what I'm doing. So I've got -5x minus 5y is -50. And I'm going to add that to 5x plus 20y is 125. My x's cancel. I've got 15y is 75. So y equals 5. Well, I knew that x plus y equals 10. So I can substitute that back in. I've got x plus 5 is 10. So x is 10. Whoop, talking too fast. So x is 5. So what does that tell me? Well, that tells me I need 5 ounces of 5% hydrochloric acid and 5 ounces of 20%. hydrochloric acid. Oh, I'm really proud of myself for remembering that. See, even if I can't subtract 5 from 10, I remember the notation for HCl.